Quantum physics has grown to be an emergent and very popular topic to discuss in the realm of science and technology. Though how does it relate to electronics engineering? Well, there's quite an interesting problem pertaining to the feasible size of semiconductor manufacturing that Professor Andrea Morello talks about in the link below. Here, he covers one of the most foreseeable limitations of classical transistor technology. That is, the size and space between nodes. As I have covered in previous videos, a primary function of a transistor is to be used as a switch. When no voltage is applied to any of the nodes, the transistor is basically an open circuit. But when you put a certain amount of voltage in the right places, the silicon material will start to conduct, thereby closing the switch. Now this works perfectly fine for a TO92 package, ICs, and microchips, as one of the greater advancements of semiconductor technology is that engineers have been able to print the junctions of a transistor in near nanometers, which has given us the ability to print billions of switches in one small package, like a computer processor. But as Morello describes, the problem with semiconductor manufacturing is that if transistors are printed any smaller, the nodes would virtually make contact, as the electrons between the nodes would effectively touch and see their way into parts of the transistor that they normally wouldn't have while operating in an off condition. So in sum, we are nearing the point of which we can't make transistors any smaller without them trying to conduct on their own. But rather than trying to find some way to evade this problem, quantum engineers are trying to find a way to work with it. Here, quantum engineers are trying to find ways to harness the advent of these permeating electrons, which would then lead to computing powers orders of magnitude larger than what we have today. Though there are a few hang-ups. Quantum computers of today are quite large and very sensitive to temperature, pressure, and electromagnetic fields. There also doesn't seem to be very practical use for these computers at this magnitude beyond some industrial implementations. Though I'm sure as time goes on, someone somewhere will reimagine how quantum computing could reduce the scale and increase the efficiency and speed of networks such as the internet, or even expand the field of molecular biology. Who knows?